Okay, in this section we're going to go over the volume of pyramids. So 18.2. I hope you have the song stuck in your head now. On page 937, we are going to develop the volume formula. Now, all pyramids that have the same height and the same base are all going to actually have the same volume. And what this part is trying to show is that if I took the top of the pyramid and I put it over here, we did this, it will have the same volume. Or if I put it over here and I did this, it would have the same volume because of the Cavalieri principle. So if I take something and I tilt it, it doesn't matter, it's going to have the same volume. In order to get this volume formula, they do this interesting simulation here, where we take a triangular prism and we're going to break it into 3 parts. So we're going to try and figure out the volume of this by taking each of the parts that it splits it up into. And it's kind of hard to see, especially in this diagram. So I broke it down for us down here. So there are 3 parts, and I'll show you these 3 parts right now. We're going to go ahead and take this guy, and we'll put it here, and we'll put this guy, and we'll put it here. So we end up getting our triangular prism that's broken into 3 parts. So the first thing we're going to do is try to figure out the volume of each of these 3 parts, and are these 3 parts the same as each other? Well, if we compare our base here and our base here, those are the same, and then we compare our height here and our height here, those are the same. So the purple one and the blue one have the same volume. Then if we compare this base here and this base here, and then we compare this length here and this length here, these 2 have the same volume, which means that all 3 of them have the same volume. And if we can take all 3 of these and stack it on top of each other, like I did in the original one here, and they end up making our original shape, which was a triangular prism, then what that means is that each of these shapes are all going to be a third of the prism. And this shape is a pyramid. This shape is a pyramid, and this shape is a pyramid. That means that a pyramid is 1/3 of the volume of a prism. And that's what it's trying to show here. And it turns out we could break it into any way. We will always get the same formula. The formula being that the volume of any pyramid is the area of the base. That's what the giant B means, the area of the base, times the height. The volume of any prism is area of the base times the height, but in order to figure out a pyramid, we just multiply that by 1/3. So let's go ahead and apply that formula to some problems. It says here that Ashton built a model square pyramid with the dimensions shown. What is the volume of the pyramid? So our pyramid volume is going to be 1/3 area of the base times the height. It looks like we have a square pyramid as our base. So we're going to say 1/3 24 times 24 times 16. So 24 times 24 times 24 times 16 divided by 3 gives us 3072. So our volume is 3072 centimeters cubed. Now it says the pyramid is composed of wood blocks that are in the shape of cubes. The block has a dimension, each block has a dimension of 4 by 4 by 4. So the volume of 1 cube is 4 cubed. That's going to be 64. So what we can do is say how many wooden cubes it take for him to build the pyramid. We'll take 3072 and we'll divide it by 64. So let's take that number here, divide it by 64, and it takes him approximately 48 blocks. Turns out this next problem here about the Pyramid of Giza is actually a very close to the actual example. I looked this one up last year. So it says here that it's 146 meters tall. It's 230 by 230. So let's go ahead and use our formula. So our volume is 1/3. The area of the base is 230. So 230 squared times the height, which is 146. So 230 squared because it's a square. So 230 squared times 146 divided by 3 gives us a large number. Maybe I can just pull that over. No, maybe not. Screenshot. Yeah. Okay, so that's going to be our meters cubed. And it says some dimensions about a block. So each block is not actually a square this time, instead of like the model that he had up there. It's 1.3 by 1.3 by 0.7. So we're going to go ahead and multiply those, and then we'll divide our number by that number and see how many blocks approximately it took. So 1.3 meters times, don't make 1.3 meters times 1.3 meters times 0.7. And we're going to take our 2, 5, 7, 4, 4, 6, 6. I could do a couple of sixes, that's fine. Divided by our previous answer. And it took us, looks like 2,176 blocks. Yeah, I'm not going to write that number down. But there you go. All right, the next part we're going to do is talk about composite figures. And there is a easy way to do this problem, and there's a hard way to do this problem. And I want you to start thinking about easier ways to do problems. Now, the way that we can think about this is it is a cube, and we are removing a pyramid. So I could say the volume is going to be a cube, which is our 25 times 12 times 15. And then we could subtract our 1/3, 25 times 12 times 15, because that's going to be our volume of our pyramid. But notice that these numbers are the same, which means that if I take a whole of something and take away 1/3 of something, I'll be left with 2/3 of that something. So the volume of a rectangular prism with a pyramid removed that is the same height as our rectangular prism is just 2/3 of our dimensions. So that'll save us some time there. So let's do 2/3 times 25 times 12 times 15. And it'll give us 3,000. That's a nice number. 3,000 feet cubed. Why don't you go ahead and pause the video to do this problem yourself. It looks exactly like the one that we just did above. So go ahead and try. All right, so I'm going to say the volume of this shape is going to be 2/3 of 30 times 12 times 15. So I'll type that up here. The reason I'm using this calculator, by the way, is because my graphing calculator ran out of batteries and I don't have a charger at home. So 3,600. So it's just going to take a little bit more time for me to do problems, unless I pre-do them all. Why don't you go ahead and do these two problems here? And just to save time, we'll go over them live. So go ahead and do number 5 and 6. This is going to be two pyramids stacked on top of each other. Those two pyramids end up being the same, so you could just take one pyramid and multiply it by 2. This one here is going to be these two pyramids. You could just multiply those by 2 and add it to the rectangular base. And then your assignment is 1, 4 through 9, and number 12.